Okay, I'm going to take a look at that same quadratic equation that we just looked at, but this time I'm going to solve it using what's called completing the square. So there are several ways to do this, but the way that I like to do it is I first start off by moving the number, the constant, to the other side, which it's already there. So all I have on the left side are things with x's in them. Now what you do is you look at the number that's in front of x squared and you divide every single term by that number. So I'm going to divide everything by 2. When I divide this by 2, I get x squared. When I divide this by 2, I get 1/2 x. And then when I divide the right side by 2, I get 3/2. Okay, so that's the first step. Now, the next step is to take a look at the number that's in front of the x term, which is -1/2. And what we're going to do with this, first thing we're going to do with this number, and this is like scratch work over here, we're going to take this number and we're going to divide it by 2. So I'm going to divide this by 2. Now, division by 2 is the same as multiplication of the reciprocal of 2. So it's really like multiplying by 1/2. -1/2 times 1/2 will give us a -1/4. Now you may be asking, do I use 2 because there's a 2 here? No, you always use 2. So even if this had been like a -1/3, you'd still divide by 2, which means multiply by 1/2. Okay, so once we have this number here, we now take that number and we square it. And when you square it, you square the top and bottom. That'll give us 1/16. And remember, when you square a negative, it becomes positive. So now we have this 1/16. Now what do you do with that 1/16? And why are we doing this method? Well, it turns out that if you take the original equation here, this part right here, and to the left and right side, you add this 1/16. So I'm taking 1/16 that I just found, and I'm adding it to both sides. What'll happen is this right here is guaranteed to factor, okay? And it's what we call a perfect square trinomial. It'll factor to be x. Now, the number that comes here actually comes from this. So if you put this number right here, -1/4, you're guaranteed that if you were to multiply this out and expand it, you would get back this, okay? Now on the right side, all you have to do is add these two numbers together. So let me add these two numbers together. I'll get a common denominator. I need 16 down here. So I multiply the top and bottom by 8. 8 times 3 gives me 24. 8 times 2 gives me 16. Now I still have the 1/16. And now I have x minus 1/4 squared equals, now if you do this over here, that's 25/16. Okay, now at this point, we're still trying to get x by itself, but what we can do is we can take the square root on both sides. So I'm going to take the square root here, I'm going to take the square root here. Remember, anytime you do the square root, you have to do plus or minus. So when we do that, the square root of something squared on the left is just x minus 1/4. So it kind of kills off the squared here. On the right side, we have plus or minus. Now, square root of 25/16, you do the square root of each one individually. So the square root of 25 is 5, and the square root of 16 is 4. Okay, we're almost there. We need to add 1/4 to both sides. So we're going to have x equals 1/4. Adding 1/4 is going to kill it off here. Over here we have 1/4 because we added it, plus or minus 5/4. So this represents our two answers. The first answer we get when we add these two together. The second answer we get when we subtract. So let me get our first answer. First answer, I'll do 1/4 plus 5/4. This is equal to, let's see, 1 plus 5 is 6/4, which reduces to be 3/2. Our next answer, second answer, is what we get when we do the subtraction, okay? So we subtract now 5/4. So 1 minus 5 is -4, and then over our common denominator 4, and this turns out to be -1. So this gives us the same two answers that we had from the previous example, but as you can see, we used a different technique. I would say this technique is a little more tedious. If you can factor, then go ahead and factor. But it's important that you know this technique, completing the square, because it comes up later on, especially in pre-calculus and calculus.